Okay, class. So this is the other page. I'm just going to go over a few of them. And the first, there was several people that had um, written that the first circuit diagram, 1A, is a parallel circuit. But this is actually a very simple circuit. It's a series circuit in which the voltmeter right here is drawn across this load, across that the light bulb. And that's how voltmeters are drawn in circuits and placed within real circuits. They have to be placed across whatever they are measuring. So if it's a light bulb that is being measured in terms of voltage or potential difference, by the way, voltage and potential difference is the same thing. I'm going to talk about that in more detail in the next lesson, but it basically those two terms represent the same thing. And so the voltmeter is always placed in parallel to whatever it's measuring. So if you put you wanted a voltmeter to measure the potential difference of this cell, you would have to place the voltmeter across that cell and not within the wiring, within the circuit. It has to be across. Okay, so that's one thing I wanted to make sure that you know, that the first diagram here is a example of a series circuit. The electrons are flowing from the negative terminal of the battery. Okay, this is electron flow, and this is counterclockwise. Okay, and you can draw your arrows there, and the current will flow through that switch, through the light bulb and the voltmeter, and back to the positive terminal of that cell. The second diagram here again is also a series circuit, counterclockwise again. Current is moving through the switch, through two light bulbs, through electrical motor, and then the current is being measured right here by an ammeter. And again, the ammeter is also, it's a device that measures current. Unlike the voltmeter, it is placed within that circuit, within the wires. Okay, you don't place the ammeter across an electric motor, for example, or across the energy source, or across a light bulb. It has to be placed within the circuit, like it has right over here. Third one is also a parallel circuit. This switch is open, so basically these light bulbs wouldn't turn on, but the electron flow stops here because of this break in the circuit. But if it's closed, the electrons will flow counterclockwise through either this path or this path. Okay, there's two alternative paths there. This next one, fourth one, is also a series circuit. And then right over here, this is a parallel circuit in which the second bulb has a voltmeter attached across in parallel. Therefore, that voltmeter is measuring the potential difference of this bulb. Okay, and one thing that I'm going to talk about in another lesson, but I thought it makes sense to talk about it here, because you were doing that gizmos activity earlier today, and you noticed there's differences between the brightness in bulbs when you are looking at a series circuit compared to a parallel circuit. So what you probably saw, hopefully, by using those variables in the gizmos activity, the simulation, that when you had one bulb within a series circuit, it's quite bright, and when you add a second or even a third bulb, you probably noticed that the bulb brightness was reduced. So they became dimmer after you added them. you added additional light bulbs. And the reason why this is happening is because every time you add a bulb in a series circuit, you're adding resistance to the electron flow. You're slowing the electrons down. So you're basically reducing the current, okay? So therefore, that those bulbs are not going to be as bright as they were as that single, bulb was if it was only just by itself. In a parallel circuit, however, you probably noticed that each bulb, even if you started off with one bulb and you added another bulb in an alternative path and another path with a third bulb in there, you probably noticed that all three bulbs within their alternative pathways had an equal brightness, and that the first bulb right here was no different from this second or third in terms of brightness. So the brightness of the bulb did not reduce. They did not become dimmer as you added more bulbs. And the reason for this is that in a parallel circuit, each of these bulbs has a direct connection with that energy source, okay? So this bulb is connected right here. It's got a direct connection. And then if you are talking about this second bulb, it also has a direct connection with that energy source. And then that third bulb right here, it also has a direct connection to this energy source, the cell. And that's why they will draw current directly from that energy source. So they will not become any different. The only thing that becomes different in a parallel circuit is that the amount of the voltage is increased, because it needs to supply, the cell needs to supply enough current to each of these bulbs separately. So basically more current is being drawn from that cell. And that is different from the series circuit, in which those bulbs, as you add them, they create resistance and they will become dimmer. The more bulbs you add, the bulbs will become dimmer and dimmer. Okay, and that's hopefully what you saw in your Gizmos activity. And I wanted to just explain that to you. And we're going to talk about two different types of laws. And I mentioned it to you in that first PowerPoint on the circuits. One of them is called Kirchhoff's law, and basically it is the law in which stated that total current in a series circuit is equal to the current at any point within that circuit. So IT is equal to so IT, if right over here, that's the beginning of where the current will flow, IT would be equal to I1, I2, okay? That if you measured current over here, if you measured current over here, and let's just say I3 over here, those three will be exactly the same as the total current. And that was the opposite in a parallel circuit, where IT, total current, is going to be additive. So each of those separate currents readings that you get within the parallel circuit, they are all going to add up to the total current. It's not going to be equal. Okay, so I will talk to you about this later. In more detail when we talk about the Kirchhoff's law. We also have to talk about the relationship between potential difference current and resistance. So we know that each of these loads offers resistance to this circuit. Okay, that resistance basically slows down electron flow, and each of those variables have an impact, direct relationship with each other, and we're going to talk about that in another lesson. So I hope that you understand whatever was in these two worksheets. If you have any questions, please let me know, and you will be having a quiz on this next week. Sometime probably by the end of the week. I was mentioning Friday to those of you that were on the Google Meet on Monday, but I will let you know. But you should be preparing yourself for a quiz for late next week. Have a wonderful day. I will talk to you soon. Bye.